With that, let's launch in to this. Distributed systems are easy, right? And this actually lets me, or this is the reason why I wanted to maybe switch to this. Does anybody recognize any Office Space fans here? So this is kind of like the distributed systems game, right? Where we wind up having all these threads and then blocking and waiting for a thread to finish, and then we activate another thread and we try to process stuff, and then that thread blocks, and then it just, this is sometimes our lives, right? So let me stop that before, again, I run afoul of anything. So let's get back to here and kick it off. So they're so easy. Why doesn't everybody do them? Well, there are some challenges, right? I guess I should start off by just kind of going into the who am I and why am I semi-qualified to talk about them. I do want to say going into this that if anybody was here for my morning session, there will be some kind of contextual background stuff that is repeated that I kind of go in to explain kind of where I'm coming from. Thanks to feedback that I got this morning, I'm going to hopefully fill out a couple of things that I kind of blithely skipped over. This is the first time I'm debuting both of these talks, so I really appreciate any feedback if you're like, hey, what's this all about? That tells me that I skipped something that I needed to explain or have a slide for. So I really do appreciate your feedback so far. Just please keep it coming. So, but I will tell you this: even though the context of the live coding is similar, we will branch off and do some other interesting, fun things that we didn't cover this morning. So if you were here this morning, there's going to be some new stuff as well. So, who am I? I've co-authored a couple of books. I've contributed content and code to several other books, some of which even recognize my contributions. That's always nice. Others, well, I wasn't going to live off the royalties anyway, right? So it's all good. I am an architect and developer, and as you might guess from the next point, where most of my expertise has been won, it's been in the realm of Java. I was nominated and inducted into the Java Champions a few years ago for, quote, ongoing contributions to the greater Java community. It is not a monogamous relationship with regard to language. I do dabble in Kotlin quite often. Love Kotlin. If anybody has not tried Kotlin, I would strongly encourage you to. It also is very complementary to and interoperates really well with Java. So I do some Kotlin talks. That's not today, but another time perhaps. So I am a professional problem solver and a Spring developer and advocate. I work for Pivotal. I'm on the Spring team. I advocate, right? I fly and I speak and I code. So I kind of always say it combines the two things that I love to do most: code and talk. So that's my happy place. So. Thanks for inviting me here, by the way. Really appreciate it. First time in Lviv, first time in Ukraine. And thanks to some bad weather coming from the US, I didn't get to spend as much time here as I would have liked. So next time, right? Please invite me back. We'll do this right next time. So a few takeaways. Kind of what would we like to get out of this afternoon session? First, why use messaging platforms and where do they fit in a distributed architecture? In the interest of time, I'm going to make some basic assumptions here. If they don't apply in your case, please see me afterward. I'm happy to discuss any of this and elaborate on kind of where I'm coming from. But I'm just going to kind of start with a certain set of assumptions, and we'll go from there. First, I'm going to assume that you understand the benefits, at least to some extent, of moving from a monolithic architecture to a microservices architecture. Even if we retain monoliths in our organizations, and many of us will for a long, long time, and there are good reasons for doing so, your monoliths and other services, microservices, are going to have to communicate with other services, right? So communication is very important. Starting with the Jeff Bezos memo from several years ago, where he said, hey, look, all Amazon functionality has to be exposed via service APIs, right? You can't talk to each other anymore. That's not necessarily true. But if an interface has to be, if you have to speak to somebody to understand and be able to implement an interface properly, it's not done right. And that was his point. It has to be, the functionality has to be exposed via interfaces, and you have to stay and adhere to those interfaces. If you don't, you're fired. Very simple, right? And of course, Bezos can do that because he's Amazon. And while he didn't specify it had to be via REST APIs, that's largely the beneficiary of this kind of experiment, isn't it? Because most APIs are REST APIs. And generally, REST APIs do a really great job in many cases. But they do suffer some drawbacks, right? Some limitations. For instance, in terms of availability, when a service produces a value and another service consumes that value, they both have to be online and communicating at the same time. When you want to scale, typically you have to be able to scale somewhat in tandem, right? So you also have this, I guess I kind of already covered the availability and the scaling, but you can't easily separate things, separate services temporally or locationally. And by temporally, what I mean is they both have to be online at the same time in order for that communication, that dance to occur. So there are obvious limitations. I'm just going down my points so I don't, again, blithely skip over stuff like I did this morning. Messaging platforms reduce and eliminate a lot of these concerns, because a messaging platform gives you a lot of stability and reliability, because typically it's fielded by your cloud provider, your critical operations team. They make sure it's there, right? And by making sure it's there, it's available, so when a producer throws values into a queue, I shouldn't say queue, but into a pipeline of some form, depending on what your implementation is. I generally kind of default to Rabbit terminology, so exchanges and queues, but if you're a Kafka person, think topics, it's okay. But as long as it's in place, a producer can throw values into that pipeline, so to speak. The consumer doesn't necessarily have to be online and engaged at that point in time. So there is an element of temporal decoupling that you allow. Locationally as well, because the consumers don't necessarily need to know where that message is coming from, just that they have a message. So you're not connected. You don't have another service that's connected to you that you're interacting with right there. You just pull a message off the queue, right? Excuse me. Let's see. Oh, messaging platforms typically have delivery guarantees and retention and things like that give you certain, again, stability in your system as well. Let's see. What else do I want to cover here? Yeah, greater performance, scalability, reliability, resilience. So covered all that, I think, pretty well. There are basically, I consider, 5 primary messaging platforms. There are others and variations on the theme. But I kind of boil it all down to the big ones, right? RabbitMQ, Apache Kafka, Amazon Kinesis, Google Cloud PubSub, Microsoft Event Hubs. And even those, the other ones, other than RabbitMQ, which primarily implements AMQP, the Advanced Message Queuing Protocol, as well as a few others, but that's kind of the big one. And then Kafka, of course, Rabbit and Kafka. Most of these other ones actually offer a Rabbit or a Kafka interface, an API. So they're all, I consider, variations on a theme. They are the big ones, but that's why I primarily talk about RabbitMQ and Kafka. So let's see, what else? Spring Cloud Stream. I guess that's the next thing. I already covered that. I'm a little hesitant to run out of time because I was really flying coding this morning, and I don't want to necessarily get jammed up on the coding because there's so much cool stuff I want to show you. So I want to make sure I cover everything well, but as expediently as possible. So Spring Cloud Stream is a set of abstractions, right? If you have ever had the joyful experience of having standardized on a particular messaging platform, let's say you already have one in place, and let's say you've chosen Kafka, and then your company buys another company who's standardized on RabbitMQ. This is a bit frustrating, right? It should be a simple matter if you had the ability to abstract from that and to use something that would sit on top of either and let you accomplish your job, accomplish your mission, to implement your business functionality regardless of who provides that plumbing. And the good news is Spring Cloud Stream does that. Spring Cloud Stream is a project, if you will, that was built on Spring Integration, which integrates various different components, and Spring Boot. Spring Integration actually gives you those capabilities, the hooks that work with various different components. Spring Cloud Stream kind of focuses in on the messaging platforms part of that. Spring Boot handles your auto configuration, your dependency management, and your deployability concerns. So it's a kind of a nice combination. Spring Cloud Stream allows you to not care what's necessarily underneath. Sure, you can tweak everything, but in many cases, you simply don't have to. And the nice thing is if your company changes its standardization, if your CTO reads a tech magazine and decides that, oh my gosh, why aren't we using RabbitMQ? We should be using that. Throw out all of our Kafka stuff and retool. Well, guess what? You don't have to worry about that because you can simply bring in a different set of dependencies and Spring Boot's auto configuration will spin up the beans that you need to interact with that just the same. Your code doesn't have to change. In fact, if you plan ahead, you can actually do that live and dynamically. I don't think there are a ton of use cases for that, but it's a nice capability to have just in case, right? Let's see, what else? You also can bridge the gap. You can bridge the two. And we'll be showing that as we go through, because I think that's kind of a fun and extremely useful exercise as well, because we probably all have been placed in this situation at one time or a dozen, where we have multiple competing technologies that we have to somehow make talk. And if you have to do that all by hand, that's rather tedious and time-consuming and fraught with peril, right? But if you have a set of tools that have been battle-tested and tried, that makes it a lot easier for all of us, so we can get back to what we really want to focus on, which is knocking out those user requirements and user stories so we can get a nice bonus, right? Okay, so what else? I guess, yeah, why use it? We've already kind of covered that as well, so let's code. And hopefully it won't turn out this way. Those of you who are already following me on Twitter have probably seen the sagas. My MacBook is having a hard time. I don't know really why, but it keeps crashing on me. It made it through one session. As long as it makes it through another, my company has already sent me a new one. It should be at my house by now. So when I get home, I have the joy of actually doing a restore to a new machine and then flying out the next day to somewhere else. But yeah, it's all good. As long as it survives this session. So how much time do I have left?
25 minutes.
Tons of time. Okay, so I do need to go back and explain a couple of things that I kind of blithely skipped over this morning, and I do want to make very clear. I'm currently running underneath RabbitMQ, a RabbitMQ instance, and I also have Kafka running, so Kafka and Zookeeper, of course, to provide my underlying messaging platforms that we're going to be working with today. And what the whole stream cloud stream architecture basically summarized in a few words is that it provides and exposes for you different interfaces. So you have an output interface, which kind of makes sense. You have a source, I should say. And the source, you can provide an output and send stuff to a pipeline, right? You have a sink, which catches the messages on the other end of the pipeline. And that takes an input of what pipeline in name, like a destination and a group that you're going to be pulling from. And then you have a processor interface, which incorporates the two. Because what it does is it grabs values from an input and it processes them and then passes them on to an output. So that's kind of what we're going to be coding here. A source going through a pipeline to a processor going through a pipeline to a sink. And we'll start off with Rabbit. I like Rabbit really well. It's got some really great capabilities. But again, doesn't really matter where we start because we're all going to wind up in a different spot anyway. So, does anyone recognize this? Still the same as this morning if you're in the morning session. The Spring Initializer. It's your starting point for Spring Boot-based microservices on the web. You can specify to the nth degree all that you want to provide here via the full version. You can check off your dependencies off of a list. And it version synchronizes with the version of boot that you're using. You can choose jar or war packaging if you're still stuck with application servers. Unfortunate, but it happens. You can go with Java version 8 on up. 8 and 11 are long-term support. We also do best level support on the interim releases, but obviously these are the ones most everyone's running anyway. And I like to go back to the simple version because I'm a simple guy. So this gets us started and running quickly. It actually lets you choose different starters. Because in any application you write, you don't just have one thing that you bring in. You have a capability you want to provide, right? So if you want to expose a CRUD app, you may have a web-based app. You're probably going to be talking to a database. And this implies a certain set of functionality, right? Which is probably split across several libraries. We've simplified the dependency management using Spring Boot. So if you say you want to provide a web app, it brings in all the stuff you always have to have for a web app. So I'm going to choose a few of these. And it'll zip it up and download the app or the project. And it doesn't generate code per se. I mean, it does do the main application class and the main method, but it gets you your starter with your dependencies. So you're off and running quickly. If even in the opinionated starting point with the simple version, you can have certain choices at your disposal. So if you're a Maven developer, you can generate a Maven app. If you're a hipster, you can generate a Gradle app. Now, I'm not feeling very hipstery today, so I'll stay with Maven, but another day perhaps. And today this afternoon, I'm going to be focusing on current capabilities in Spring Cloud Stream and how they're typically used in your typical imperative Java app, which most of us code in most all days, right? This morning I kind of talked about the future, right on that bleeding edge and reaching out a little bit past that. Now we're going to be talking about where we are today and how best to use the capabilities we're probably all using in our organizations, or maybe should be, right? So I'm going to use the current version of Spring Boot 2.1.3. I'm going to change this to the Hecklers because it's my domain. And then for our artifact, let's see, we'll just do a DFTS, drinking from the stream, and we'll create our source, right? So let's bring in a few dependencies. I'm going to bring in the standard web dependency, which is Spring MVC and Tomcat, as you see. And of course, it defaults to Tomcat for the servlet engine. You can choose to use Jetty, Undertow, whatever. But I'm going to stay with Tomcat. That's cool. And then I'm going to bring in Cloud Stream. And then, let's see, I need a binder, so Rabbit, MQ. I'm also going to bring in the Kafka binder because we're going to switch this around a little bit, as I said later. And I'm going to bring in Lombok because I'm a lazy developer. Lazy good, not lazy bad, right? This helps me eliminate a lot of boilerplate if I'm not using Kotlin, which is when I really kind of miss Kotlin. Okay, so let's see, we're going to put this out on my desktop, and we'll just save it there. And let's go out to the desktop, and we'll open that up in our favorite IDE, NetBeans. Just kidding. I actually like NetBeans. For those of you, I'm not trying to diss NetBeans. The only thing I really truly hate is Emacs. I don't understand how that ever got to be a thing. Any Vim people in here? Okay. Any Emacs people? Yeah, I was going to say, I'm not sure anybody will be brave. Oh, really? How did you get in here? I'm kidding. I'm kidding. It's all good. No, it's just kind of a running joke between my colleague Josh and I. I don't know why he likes Emacs, so it breaks my heart. I tell him every time he starts Emacs, a puppy dies. But he doesn't care. I don't know. Anyway. Okay, so the first thing I'm going to do is go to my POM. And as you can see, we've got a couple of things mixing in here. We've got our AMQP support and our Rabbit binder. And I'm just going to bring those down together. And then we have our Kafka binder. I love how this does this, pseudo-alphabetically, but not close enough to where it just makes it easy for me. So I've got my Rabbit binder here and my Rabbit starter. And then here I've got my Kafka binder and Kafka starter. Now I'm just going to comment out the Kafka stuff. Well, I will here in a minute. I'm going to do something else first. So I'll go to my application properties, and let's define a few basic getting started properties, some sensible defaults. So I'm going to set the server port equal to 0 so I don't have any port conflicts. Those are always bad. And then I'm going to indicate my Spring, Cloud Stream, tiny little navigation keys. So my bindings, this is a source, so I'm going to bind it to an output, right? And I'll just choose my destination. I'll send it to a queue, actually an exchange to a queue called processor. So I've got my destination and my group. So that's my exchange and my queue, right? Okay, so now I'm also going to, I think I can stop there on my source. Yeah, that's probably fine. So I'm just going to comment out the Kafka stuff here. And then let's go to our main application class. And main application class, what happened there, IntelliJ? Okay, so let's get started really quickly. You always have to have some kind of a demo domain. As I used this morning, I'm going to stay with subscriber because that way I can just auto code on that, and then we'll take out with the different stuff later. So I'm going to create a subscription model. So this is an application or a system with which we track subscriptions to our product that we're selling as a company, our new company, our JavaDay Lviv company, right? So I'm going to use Lombok. So that I'm going to use the app value annotation, which gets me my all-args constructor, my getters, setters equals hashcode toString, and I'm going to create a class called subscriber. And by the way, those of you in the front row, you have to spell check me before I hit build, okay? Just so you know. If I hit build and there's a typo, it's all on you. So, okay, so we need an ID. We'll need a first name of our subscriber, a last name of our subscriber, and then we also will need a timestamp for when that person subscribes, right? Come on, there you go. Subscribe date. So that's good enough to get us started. The next thing I want to do is create a generator of subscribers so that we can, again, have some subscribers we can pass down the line and feed into our pipelines here. So I'm going to create a component, again, spelling counts. and this will be our subscriber typing is hard, generator. Okay, and let's see. What do I need to do? I need to create a string. We'll just do a string array to do some last names here and first names. So first names equals. I fly a lot, as you might imagine. I travel all the time, so I practically live on airplanes. So I like the aviation phonetic alphabet really well. So I use that kind of as my sample data. So Alpha, Bravo. So these are names now. Charlie actually works. Delta. Yeah, I started with United. Oh, heavens. Echo, Foxtrot, Golf, Hotel. And we're just going to split those using a comma, not a K, a comma space. There we go. And let's duplicate that for our last names. And then I want to create, actually I could just make this final, right? Yeah, let's do that. Final. Okay, so final, let's see, random, RND equals new random, boom. Okay, that's cool. So let's start with that, and then we need a couple integers, I and j, and that gets us off and running. So now we need to, let's see, what do we need to do? I need to, actually that's probably sufficient as it is. So subscriber, I'm going to provide a subscriber using my generate method. And let's see, so return new subscriber, right? Let's see, so we'll use a uuid.random.toString for our ID, and then first names I, so we get some randomness going here, sort of, pseudo, and then j, and then instant.now, so we get our timestamp. So that's good. So that should get us rolling for our generator. So now we need to create our actual, our stream emitter, if you will, the thing that's going to provide those values. So I'm going to first enable binding, and we'll enable binding to our source.class. And this again is our Spring Cloud Stream interface we're connecting to. I'm also going to use enable scheduling, so I can schedule this to send out a pulse every so often, just kind of automatically. So this will be our spammer. I'm going to create some spam here. So I want to inject my subscriber generator, and we'll do constructor injection because that's better for testability. And then what I need to do here is my post construct method, and we actually need to make this a stream emitter. No, I can't do stream emitter here. I'm getting turned around with my reactive stuff here. So I do need to do a scheduled, right? Fixed rate equals, we'll do 1 per second. And that should be okay. An output. I need to provide the output, right? So that will be our source.output. Yeah, there we go. So now we just need to, and actually, nope. I need to inject my source, because this actually in my source, I need to have access to this and use it. So private final source, and we'll again constructor inject that. So then we can just do a, how did that get there? There we go. So private void send, and we will just do a source.output.send. We'll use message builder to build a message, right? Clever. And dot with payload, and we'll do a generator.generate and build the message, and we're off and running. Should be. We probably need to create the processor in the sink before we fire up the source, so we're not just sending values out into the pipeline. We could, but let's do it right? So let's create our processor now. Proc, just proc, that's cool. We'll generate our project once again. We'll go out and grab that. Come on, there we go. Unzip. And open that. Always a little concerned about leaving my water open anywhere close to my MacBook. A colleague of mine I learned this lesson a long time ago not to do this, although I think it's safe here because it's a flat surface. A colleague of mine about 2 months ago had a small podium, and he had his water sitting right by his Mac, and it went right into it. And immediately it just kind of fizzled, but he dumped it out and it kept going. So he's like, oh, I think we dodged it, and it shut down. It was sad. He was sad. He was really sad. So, but I think we're okay. So the same thing here. I'm going to grab the AMQP dependency here and bring that down just for manageability with my rabbit. And then I'm going to grab the Kafka and bring it together here. And then let's, actually, again, I'm going to go ahead to my application properties, server.port equals 0, Spring Cloud Stream bindings. Now, this is our processor, so we have an input to define and an output to define because we're going to process in the middle, right? So input dot, let's see, destination equals processor. That was what we defined earlier. And then let's duplicate that for group, same thing. And then we're going to do the same thing here for our output. Spring Cloud Stream bindings, output dot destination equals sync. We're going to pass this on to our sync, so our sync can use it, and group. And then I'm going to define some things preemptively for when I switch over to Kafka later. So I'm going to just say my auto add partitions is true, and then Spring Cloud Kafka binder minimum partition count. I'm going to start off with 4, so that's cool. Now I want to go back over and just comment out my Kafka stuff, and that way we've got that put on hold for the time being. Application. Okay, once again, we're going to just at value, class subscriber, private, string, ID, first name, last name, private, instant, subscribe, date. Perfect. Okay. Now this is actually a lot simpler, right? We're just going to process stuff as it comes in. So I'm going to create a class called message processor. Ooh, piece cake. No problem. Okay, so he says, right? I'm going to enable binding, and this is binding to our processor class, right? And we need to make this our message endpoint. And then what else do I need to do here? Let's see, I need to bind stream listener here. So we've got our processor dot input, right? We're going to listen on input, and then we're going to send our output to processor dot output. Clever, right? So let's see, what else do I need? I'm going to return a subscriber, and let's see, transform. We'll just transform this. And we're expecting a subscriber. We'll just make that sub. Now, how do we want to transform this? I'm going to keep it pretty simple so we can get on to the good stuff and not necessarily spend a lot of time on what we're transforming. So we'll just take our sub and return new subscriber based on that sub. Sub.getID, sub.getFirstName. Well, let's lowercase this just to add tons of variety here. So get last name to lowercase, and sub.getSubscribeDate. So pretty simple transformation, right? So let's see. I think that's it. Seems right. Okay, well, if not, we'll figure it out later when it doesn't work. Okay, so let's do our sync now and generate that project. And we're off and running with that. Open. POM. Once again, we go to our AMQP, and we'll drag this down. Here we go to our binder rabbit, and we'll grab our Kafka stuff, which is here, and bring that down as well. And then let's go to our application properties, server.port 0, Spring Cloud Stream, help me out here, come on, bindings. And since this is our sync, we really don't have to worry about an input, right? So input dot destination equals sync. And we'll do the same thing for our group. And then, of course, we want to be able to scale this, right? So I hate how that does that. Spring, cloud, stream, Kafka binders, minimum partition count 4. And let's go up here and do an auto DDL partitions true. OK, so back to our application. Come on. There we go. Application class. Again, we'll do our app value, class subscriber, private string ID, first name, last name, private, instant, subscribe, date. Perfect. OK. So once again, we need our message endpoint. We need to enable binding, this time to our sync dot class, right? And let's see, we need our message endpoint, class, message, processor. And this, you can name it anything, obviously. I just kind of fall into a rut here. And at this point, let's see, we need to do a stream listener. And actually, I keep forgetting because with our standard imperative stuff, we can just do a source sync dot input. Look at that, so nice. OK, so void catch it. So let's see. Right, and of course that's going to catch a subscriber sub. So now we just print it out. And that should be sufficient. So let's start this and see what I missed, because chances are I missed something in there. Well, if I missed it, oh yeah, there we go. I was going to say I missed it well because it ran, but it didn't. So we default. Oh, I didn't block out the Kafka dependencies, did I? Well, that was silly. One moment, please. Yeah, look at that. So it's telling me, it's barking at me because it's saying, hey, you haven't specified. This is one really cool thing about Spring Boot's auto configuration, because if you have a default binder, or you have the libraries, on your class path for your binder for Rabbit, for instance, it'll say, hey, look, I know you want to talk to Rabbit. You say you want to have a pipeline. You're providing the Rabbit dependencies. Let me make this easy for you. So it's kind of nice. So it worked, even though I didn't. So let's start the processor. Let me check the POM. Good. OK, so that's good. So that looks right. So let's go ahead and run that. OK, that seems to work. So I probably missed something. So let's start our source. 10 minutes. Oh, tons of time. This is great. Oh, and see, something broke. So I need to look and see what it is here. Error creating bean with name spammer, invocation of init method fails. So let's take a look at spammer. Enable scheduling.
You cannot finish generate method.
I'm sorry?
Generate method, you cannot finish it. You should write.
Oh, I actually need to put this too. Source.output. Let me try that. And then we come back. Oh, OK, hold on. Let's check the stack trace. Same thing. Invocation of init method failed. Nested exception is dispatcher has no subscribers for unknown channel name. OK, enable binding source, right? Yeah, let's take a look here. Output destination processor. No, that all looks right. That all looks right. What's that? Oh, hold on. I don't even know how that happened. Oh, wait a minute. Scroll down. Oh my goodness. Oh wow, that's an easy one. See, it's always the easy stuff that kills you, right? So I equals, and next in, and I've got what, 8, right, still? OK, so 8 is good. Yeah, so let's see. So J, let's try that again. Whew. That's terrible. And it's still barfing.
You need to wrap it into array, or into loop.
Into what, I'm sorry?
Wrap it into loops.
No, that's my scheduler, actually. I've got the scheduling. It's kind of a neat trick you can use with the scheduler capabilities. Error creating bean with name spammer. Invocation of init method failed. Dispatcher has no subscribers for channel. Yes, okay, so that's... All right, well, in the interest of time, I may have to just do something and cheat, because I have a funny feeling that I've got just something that's really silly that I'm missing. Post construct here. I'm doing a schedule fixed rate. I'm doing my output, which actually I shouldn't even need that, really. Scheduling. Yeah, I just don't... Oh, you know what? I should need this. And if this doesn't work, I honest to goodness will check my other code that actually was running just earlier. Oh, yeah, of course. Except it's not, oh, there we go. So we've got our sync. Oh, I didn't spit out the values in the middle so we could watch that. So let me do that really quickly. So we go to our processor. I'm going to just, instead of return new, I'm just going to introduce local variable, new sub, and that way we can just do new sub, and then return new sub. There we go. Okay, so let's restart our processor, and then we'll make sure everything works, and then let's get into the kind of the fun parts, because that was just the build-up. All right, so there's our processor running. There's our source. Let's run our source, make sure everything comes out okay. All right, so here, there we go. There's a subscriber. That's our sync. So we're getting our stuff synced, and it's all lowercase. And actually, let me IntelliJ, you're killing me. It doesn't let me do the presentation mode when I have multiple projects well, so that's kind of sad. So now if we go to our processor, we see that it also is spitting those out quite nicely. So let me go back and kill our sync. Now, remember what I said earlier about wouldn't it be really cool if you could just switch to your underlying messaging platforms? Let's do that, because that's good, clean fun, right? So I'm going to bring Kafka back into the mix here, and we're going to comment our rabbit stuff out. And automatically, this should pick this up. So that's our sync. Let's go ahead and restart that. Sync is up and running. So you can see here that Kafka was booting up here, or connecting, I should say. Processor, once again, oh, I haven't stopped my, my source. How sloppy. Okay, so we'll go back to our processor, and we'll go to our POM, and here we'll comment out our AMQP dependencies, rabbit, and uncomment Kafka, and then we'll restart our processor. And then let's go back to our source, and we'll start that. Oh, actually, I need to change the source, Kafka as well. This is a really tough day's work, right? So you'll go back to your boss, and they're like, oh my gosh, you've got to change everything, and we're going to use Rabbit now, and you've been using Kafka, and you're like, I need at least 6 months to get that done. And then here you go. So let's see. So why is data not coming through here? That's the big question. So we'll stop the source. Well, that's embarrassing. That's just embarrassing. Stop here. We've got Kafka. We have Kafka in our source, and our sync is running Kafka. So let's go ahead and restart. Did I define my properties? And here's where it gets interesting. Okay, so sync. So we're back up and running using Kafka. Right? Yep. And then we go to our processor, Kafka, input, processor, output, sync. That should be good. Kafka, and we go back to our source, and we'll restart that. And processor. Okay, so that's good. There we go. I don't know exactly what happened there. I must have not restarted something. So we've got everything running. Now, let's stop our source for just a second here. And actually, you know what? Let's do something really fun here, because I mentioned earlier you can scale this very nicely. So let's go here and go to our edit configurations, and we'll allow parallel runs. So we've got our sync. Let's go ahead and start another one. Now, I said minimum 4 partitions. So we were pulling in all 4 partitions or servicing all. Oh, recording stopped, and there goes the Mac. Okay, well, let's see what we can salvage here. Oh boy. I've never seen this do this. Not quite like that. Every time is a new experience. Okay, so here's our sync. It's running along. We've got 2 instances of it. And as you can see, when I restarted that. Oh dear, okay. Oh, much better. Okay. So here we can see that oh, it keeps flashing and trying. Well, it's looking great from here. If anybody wants to gather around, we'll finish it. Yeah. All right. Okay. So we're running here. We've got both instances running. I'm going to go ahead and start another one, and you can see that it goes ahead and changes what topics it's servicing, or it shares the load. So here we've got sync 2. This one is now handling sync 3. This one is handling syncs somewhere in here, 0 and 1. Yeah, so we've got everything handling that nicely. I can do the same thing for processor, but since we're close on time, I just want to show you how we can bridge the gap between the two, because I think that's actually some of the coolest stuff that when you're called to do this makes a really big difference. So our source, I've stopped, so then I can go to my processor, and we will just enable both sets of dependencies. So now, how does Spring Cloud Stream sort this out, right? Very simply, for our input, let's see, what did I do? For our input, for our source, actually our source, I'm going to change this and use Rabbit. And for our sync, I'm going to still use Kafka. Yeah, and then for our processor, I'm going to use both. So now we're up or should be up and running with our source using Rabbit. For our processor, I'm going to indicate Spring Cloud Stream Bindings input.binder equals Rabbit. So we're going to grab stuff off of our Rabbit exchange and queue, and we're going to push it to a Kafka topic here. So spring.cloud stream bindings output.binder equals Kafka. It's as simple as that. So let's go ahead and restart this. Are we close on time? 10 minutes?
About 10 minutes.
Oh, awesome. Oh, this is great. Okay.
Yeah, but if someone wants to have a coffee, because we have a coffee break.
Okay. Yes, if you need coffee, believe me, I understand. It's all good. So I'm going to go ahead and restart the source. So the source is going to be feeding a Rabbit MQ pipeline, if you will. The processors are going to be listening on that and then grabbing it, transforming the values, and pushing those values now to a Kafka destination. Oh, here's our sync. Let me go to our processor. So we see that it's getting these values, it's transforming to lowercase everything, and then it's going ahead and pushing them out to a Kafka topic here, and sure enough, it's all running. Isn't that cool? Now, how much effort did that take? Don't tell your boss, but you have the power now. It's all built in, so that's kind of nice. So let's see, I've handled the scaling stuff. Let's see if I go to processor, and we want to do the same thing for processor. We want to scale this, allow parallel run. So let's do that. Let's go crazy here. So, yep, So now we've got things kind of processing here. We got both of those processing. We go to our sync. We have 3. Why not start a 4th? So it allows you to scale independently. And again, using messaging platforms, but you can even scale independently regardless of which or how many messaging platform you're using too. So now we've got sync 1 being serviced by this instance, sync 2 here, sync 3 here, and was that 3? Yeah, 3, and then this should be 0. So piece of cake, right? All in a day's work. Okay, so with that, I will actually kind of bring this to a stopping point and go back, because sometimes I forget to close out with the resources, and that's sad, and then we may have some Q&A time, or we can go have coffee and have Q&A time, or whatever you want to do. So, okay, so resources. So here are some helpful resources. The top link is the repo with all the code that you saw and then some, and I will be maintaining and adding to that as time goes on. Again, this is the debut time. This is the first time I've ever debuted this talk, so I will be evolving and changing this based on feedback you may have. So keep an eye on it. Watch it, start it, whatever. But I will be modifying it and updating as we go. Spring Cloud Stream project page, which actually gives you the documentation and examples and whatnot. That's really nice. You can reach me by email, but I don't watch email quite as closely as I do the next one, which is Twitter. I live on Twitter. Occasionally, I'll take a couple hours a day to sleep, and sometimes I'm on a plane with no Wi-Fi, which is really sad. But other than that, I'm pretty much always on Twitter. So if you have any questions, comments, or feedback, shoot them to me. If you don't want to send me anything publicly and just want to kind of, hey, I've got a quick question, my DMs are open as well. So reach out to me. Happy to discuss this at length, obviously, anytime. And thanks for coming.